It's convenient to be able to plot these cost functions, and we call them the cost curves. So in the short run, we're going to call these the short run cost curves. So if we plot the cost function, we're going to put the cost on the vertical axis and the quantity on the horizontal axis. So as the quantity you produce increases, the cost, of course, is going to go up. What we can do is then split the cost into the fixed cost and the variable cost. Now the fixed cost isn't going to vary with quantity, so it's going to be a horizontal line where the intercept of the cost function is the fixed cost. So we draw a horizontal line at the fixed cost. Now remember, the variable cost is such that it depends on the quantity produced, and at zero, you're going to have, if you produce 0 units, you're going to have 0 variable cost. So the difference between the cost curve and the variable cost curve, if you subtract variable cost from cost at any quantity, this height is going to be f, the fixed cost. So you're going to get a curve that's parallel to VC is going to be a curve that's parallel to C, and the distance between the two vertically is going to be f. Now, how are we going to get from, remember, this was our cost curve. How do we get from this thing our average cost curve? And we're going to want also the average variable cost and so forth. If you go back to the last chapter, we had our production function. And from our production function, we were able to draw the average product and the marginal product. Now, if we're going to use the same idea here to graphically get the average product at a given quantity. So let's suppose at quantity 5, we wanted to know what the average product was graphically. What we're going to do is we're going to take a line from the origin. We're going to draw a straight line to meet the cost curve where quantity equals 5. The slope of this line is going to tell us what the average cost is at quantity 5. So if this cost curve is such that this slope is 175, then at quantity 5, the average cost is 175. Remember, the reason we draw this line from the origin to this point is because slope is rise over run. How far is this rising? This is the cost at 5. How far is it running? Well, it's 5. So this slope is going to be cost at 5 divided by 5, which is the average cost at 5. In general, for any given Q, if we draw a straight line to this point, we get C of Q divided by Q is the average cost at Q. But then this height is C of Q. This distance is Q. So if we divide by rise over run, we get the slope of this line as being the average cost. Now, if we look for this point A, where the slope of that line would be lowest, right? So if we draw lines from the origin to all the different points on the cost curve, the flattest one is the one that touches the cost curve at A. So remember, the slope of this line tells us what the average cost is. So the point on the cost curve where the line from the origin is flattest is actually going to give us the point where the average cost is minimized, because that's the least slope for one of these lines. So we see then that the average cost in this picture for this particular cost function, the average cost is minimized at this point A, where the quantity is 15, and the average cost is 115. Once you move to the right, again, the average cost starts increasing. So average cost is going up here. You move to the left, average cost is going up, and it's minimized at A, at 15. Okay, now if we wanted to find the average variable cost, we would do the same thing, except we would plot the variable cost curve. We subtract from C the cost F at every possible quantity. So everywhere we subtract F, so we just shift this cost curve downwards by F. And that gives us the variable cost curve. And we do the exact same thing. We just draw these straight lines from the origin to touch the variable cost curve. And we find that the variable cost curve is minimized at B instead of at the quantity 10 instead of at the quantity 15. So we find this point right here as the minimal average variable cost. Where am I getting these numbers from? These numbers are just from this example. Now, what about the marginal cost? Remember when we were looking at the marginal product and the average product, we had a similar relationship between the average product and the marginal product. We're going to see here that if we draw the slope of the tangent at each point to the at each quantity, we draw the slope of the tangent, we get the marginal cost. Since the cost curve and the variable cost curve, at every point, the difference between the two is just a fixed cost. So they're going to have the same slopes. So the marginal cost or the marginal variable cost are going to be exactly the same. And that makes sense because the marginal cost is just the derivative of the average variable of the variable cost. So we could then plot the marginal cost curve. At each point, we just look at each quantity, we look at the slope of the tangent to that, to the cost curve. An important thing to note here is that at the minimum cost, average cost, the line from the origin is tangent to the cost curve. At the minimum average variable cost, the line from the origin is tangent to the variable cost curve. This means that when we look at the average cost and we look particularly at the minimum average cost, so we look at the quantity where average cost is at its minimum, well, the marginal cost is going to have to equal the average cost. Similarly, when average variable cost is at its minimum, the marginal cost is going to be equal to the average variable cost. In other words, when we plot the marginal cost curve, it passes through the average cost curve and the average variable cost curve at their bottoms. What about the fixed cost? Well, the fixed cost is always just going to be this decreasing function, right? Because it's just going to be f divided by q. So it's going to be a function that looks like 1 over q, scaled by this factor f. So those are all of our cost curves.